So let's look at this problem where y is a random variable that has some relationship with random variable x. So I'm interested in the random variable y, but I don't get to observe it directly. I only get to observe x. And what I want to do is I want to estimate y as a function of x. We'll call that function phi of x, such that the mean squared error is minimized. So let's kind of write out what that means algebraically. So we want to choose the best phi of x, which is the argmin over all possible functions of x of this mean squared error. Okay, so remember, we observe x, right? So x is just going to be a number. And phi of x will just be a transformation of that number, right? So this entire term here is just a constant. It's not a random variable. So we're going to treat it like a constant, and to kind of emphasize that and clean up our notation, I'm going to define c to be phi of x. C is just a number, and then we'll optimize over that number. So kind of rewriting this, we're going to have the argmin over c. That. Okay, fantastic. So now let's work on finding this optimal c. So the first thing I'm going to do is FOIL out this expectation term here. So let's do that. All right, cool. So now that we have that, let's apply linearity of expectation. So breaking up this big expectation into smaller ones, we have the expectation of y squared Okay, cool. So looking at this first term doesn't depend on c at all, right? So we can just ignore that for the purposes of our optimization problem. And then this third term here, remember, c is just a number. It's just a constant, right? So we can get rid of the expectation. We can just write that as c squared. All right, cool. So if we were to graph this objective function with c on the x-axis, we're going to get some kind of upward-facing parabola, right? So to find this c that's the minimizer, we can take the derivative and set it equal to 0. So let's do that. Okay, so taking the derivative. Cool, and then solving for c, we can get rid of these 2's here, and then move this first term to the other side. So we have c star, our optimal c, is equal to just the expectation of y, given x equal to x. Cool. So this here is what we're looking for, right? This is a function of x that is the MMSE estimator for y. So the minimum mean square error estimator of y, also known as MMSE.